Welcome back. We have a problem here where we're dealing with some stoichiometry involving solutions. So, just like any stoichiometry problem, we're dealing with mole to mole ratios. But remember that not all substances that we're dealing with are going to be solids where we can take a mass of them really easily. A lot of the time, we're working with aqueous solutions. So, concentration comes into play, and the volume of that particular solution that we use comes into play, right? And because we can calculate moles from a concentration and volume, we can do stoichiometry when we're dealing with solutions. So let's try this problem. 2 liters of hydrochloric acid solution was needed to completely react 47.20 grams of aluminum in the following reaction. Determine the concentration of the hydrochloric acid solution used. So if I'm solving this problem, the first thing I always want to do is balance the chemical equation. So if I look to balance this chemical equation, I see that I'm going to probably need to do a little bit of balancing where I got to get my CLs balanced here. So we might do this as a 3, but then all of a sudden we'll notice, hey, 3 to 2 for the hydrogen, that's not going to work. So when we balance it, instead of using the 3, let's start with a 6 for balancing. So we've got 6 HCl. We can balance that with 2 AlCl3. 3 H2s to balance the hydrogen, and finally we finish by balancing with 2 aluminums. So there's our balanced equation. And I'm just going to rewrite this down here because I'm going to do a lot of the work and show my work underneath the actual equation. But this is our reaction that we're dealing with. And there's our balanced chemical equation. So now I'm going to write down my givens and what I need to find. I know that I have a mass of aluminum, which is 47.20 grams. And remember that to get to moles, right, we need molar mass when we have a mass. So I'm going to jot down the molar mass of aluminum, which is 26.98 grams per mole. And that's enough information that I'll be able to find the moles of aluminum, right? And that's the first thing I'm going to do. Then it's going to let me figure out moles of HCl because I'll do my mole ratio and I can figure out moles of HCl. To go from moles of HCl all the way to concentration of HCl, I need the volume. And luckily, the volume is given to us in the question. We had 2.00 liters of our particular hydrochloric acid solution. So when we're working through this, remember, the first step we're going to do is find moles using the mass and the molar mass of aluminum in this case, because we have enough information we can get to moles that way. Once we've got moles of aluminum, our next step is to do our mole ratio. And then our third step, to get from moles to concentration of HCl, we're going to involve the volume here. And we're going to do that calculation to get concentration. So that's what we need to do. Let's do it. So find moles of aluminum. So mass divided by molar mass to figure out the moles of aluminum. So that's 47.20 grams divided by 26.98 grams per mole. And we get a number of moles of aluminum of 1.74944 moles. So we've got moles of aluminum. Now we're going to do our mole ratio step. So our mole ratio, we want to find moles of HCl. So we're going to set it up as the, whoops, not the mass, that's silly. We've got the moles of aluminum times, and then we need the ratio from our balanced chemical equation. Remember, we're looking to figure out the moles of HCl, so moles of HCl goes on top, so 6 moles HCl to 2 moles of aluminum. Aluminum's on the bottom because we know information about the aluminum. This will cancel it out in our ratio when we do the math. All right, so 1.74944 moles of aluminum, and we're going to multiply that by 6 over 2, which is essentially just 3. And we get 5.24 833 moles. All right, so that's our moles of HCl. So we've got the moles of HCl. We've got the volume of the HCl solution. Now we can calculate the concentration. So remember concentration. Our formula for concentration is C equals N over V. Moles divided by volume. It's a molar concentration, moles per liter. So make sure your volume's in liters, which we have. Awesome. So we can plug in our moles that we just calculated of HCl divided by our volume, which was 2.00 liters. And that will give us a concentration of 2.624166 moles per liter. But we want to make sure we've got the correct number of significant digits for our concentration. And based on the data in the question, we had 3 significant digits for the volume. Everything else was 4. Since all the math we did was multiplication and division, we want the lowest number of significant digits. So our answer should be 2.62 moles per liter. We can finish it off with a statement. Therefore, the HCl solution had a concentration of 2.62 moles per liter.